Hello. Hello and welcome to this video on permutation and combination. We will solve 13th set, that is question number 121 to 130. The link to download the PDF will be in description, and at the end I'll show you how to download the video. When I'm stating the problem, you should pause the video and try to solve the problem yourself. Only if you cannot solve the problem yourself, you should look at the solution. The other choice you have is you can leave the problem and move ahead and come back to the problem later on. So without further ado, let's get started. Question 121 says that how many numbers greater than 10,000 can be formed with the digits 1, 1, 2, 3, 4 and 0. So we are given 6 digits. We can also make 100,000 numbers. So the first case is when the number is of 5 digits. So 10,000 place can be occupied by 2, 3, 4. Hang on, 121, right? Yeah. So 10,000 place can be occupied by any of the digits actually. 0 cannot occupy it. And remaining 4 places can be filled in 5p4 way by 2 factorial ways because 1 comes twice. So 1 is missing here, okay? So 1, 2, 3, 4. No, it is taken separately, sorry. So when 10,000 place is occupied by 2, 3, 4, the remaining places can be filled in 60 ways, so total number of numbers is 180. When 10,000 place is filled by 1, remaining 4 places can be filled in 5p4, that is 120 ways. So total number of 5-digit numbers is 300. When the number is of 6 digits, the 100,000th place can be occupied by 2, 3, 4. The remaining 5 places can be filled in 5 factorial by 2 factorial ways, that is 180 total. When 100,000 place is occupied by 1, remaining 4 places can be filled in, remaining 5 actually. Remaining 5 places can be filled in 5p5, that is 120 ways. The total number of numbers in this case is also 300. So total number of numbers, and the final answer would be 300 plus 300, that is 600. Question 122 says that find the number of numbers of 4 digits that can be made with the digits 0, 1, 2, 3, 4 and 5. If the digits can be repeated in the same number, how many of these numbers have at least one digit repeated? So when the numbers are repeated or digits are repeated, thousands place can be filled in 5 ways excluding 0. Remaining 3 places can be filled by 6 digits in 6 to the power 3 ways. So total number of such numbers is 5 into 6 to the power 3, that is 1080. Now to find the number of numbers where only at least one digit is repeated, we find the number of numbers where no digit is repeated. So for no repetition, thousands place can be filled in 5 ways excluding 0. Remaining 3 places can be filled by 5 digits in 5p3, that is 60 ways. So total number of numbers without repetition is 60 multiplied by 5, that is 300. So total number of numbers where at least one digit is repeated is 1080 minus 300, that is 780. Question 123 says that how many signals can be made by hoisting 2 blue, 2 red and 5 yellow flags on a flag at the same time? So total number of permutation, of course, is 9 factorial by 2 factorial multiplied by 2 factorial multiplied by 5 factorial. There is the total number of signals made. Question 124 says that how many signals can be made by hoisting 6 differently colored flags, one above the other, when any number of them can be hoisted at once? So when all are of the same color, 6p1 signals can be made. When they are of 2 colors, 6p2 signals can be made and so on. So total number of signals is 6p1 plus 6p2 plus 6p3 and so on up to 6p6, and the sum would be 1956. Question 125 says that find the number of arrangements of the letters of the word Delhi if E always comes before I. So first case is When E is in the first place, remaining 4 places can be filled in 4 factorial ways. When E is in the second place, first place can be filled in 3 ways and remaining 3 places in 3 factorial ways. When E is in the third place, first 2 places can be filled in 3 by multiplied by 2 ways and remaining 2 places in 2 factorial ways. When E is in the fourth place, first 3 places in 3 factorial ways and last place has to be filled with I. The total number of words is 4 factorial plus 3 multiplied by 3 factorial plus 6 multiplied by 2 factorial plus 3 factorial, that is 16. The second method is the total number of words is 5 factorial. In half of these, E will come before I and in half of them after it. The number of words is 5 factorial by 2, that is 60. Question 126 says that in how many ways can 5 men sit around a table? This N should be capital. Number of ways in which 5 men can sit around a round table is 5 minus 1 factorial, that is 24 arrangements. Question 127 says that in how many ways 5 boys and 5 girls can sit, this is extra, around a table if there is no restriction, if no 2 girls sit side by side. So when there is no restriction, we have 10 total kids and number of arrangements would be 9 factorial. If no girls are to sit together, then we first seat the boys in 4 factorial arrangements, giving us 5 open positions, which can be filled by 5 girls in 5 factorial ways. The total number of arrangements would be 4 factorial multiplied by 5 factorial. Question 128 says that in a class of students, there are 6 boys and 4 girls. In how many ways can they be seated around a table so that all 4 girls sit together? So when all girls sit together, we treat them as a single girl. We have 7 boys and girls can be seated in 6 factorial ways. But those 4 girls can be arranged in 4 factorial ways among themselves. The total number of seating arrangements is 6 factorial multiplied by 4 factorial. Question 129 says that 5 boys and 5 girls form a line. This should be for, not from. Form a line with the boys and girls alternating. Find the number of ways in which a line can be made. In how many different ways could they form a circle so that boys and girls alternate? So we treat, 129. The line can start with boys, so we first seek the boys in 5 factorial ways. And girls can be followed by girls in between the boys, that is 5 factorial ways. This can be repeated starting with girls in the same manner. This number of lines that can be formed is 2 multiplied by 5 factorial multiplied by 5 factorial. For the round table, we have already solved it in the previous. So that is 4 factorial multiplied by 5 factorial. Question 130 says that in how many ways 6 boys and 5 girls can sit around a table, sit at a round table where no 2 girls sit next to each other. So we first seek the boys in 5 factorial ways, giving us 6 open places in which girls can be seated in 65 ways. That's total number of sitting arrangements in 5 factorial multiplied by 6 factorial. And with this, we come to the end of 13th set of problem. I hope that you are enjoying this series and finding it useful. The link to download the PDF is in the description, but you can also come to my website and download Algebra book here by clicking second link. You can also download trigonometry book by clicking third link for self-study. Coordinate geometry book should be available within 15-20 days. I'm working on circles and then I'll upload it and I'll keep adding new material to it. For example, ellipse, parabola and hyperbola. I'm not sure if I'll add 3D coordinate geometry, but I might add. So with this, I'll end this video and thanks a lot for watching the video. We will meet tomorrow with 10 more problems. That is problem number 131 to 140. Till then, keep practicing and stay curious.